All right, electronegativity is how easily an atom attracts an electron to itself. Technically, the ability of an atom to attract bonded electron pairs. I think that definition has gone back and forward in textbooks over time. So basically, because the nonmetals want to gain electrons, they'll have a high electronegativity, and the metals want to lose electrons, so they don't have a very good electronegativity. Those trends are useful because when you're trying to work out an ionic substance, a minus the 2, so if you've got sodium chloride, if it is greater than 1.8, it is an ionic substance. If it is less than 0.4, it's non-polar covalent. And if it's between those two numbers, it's polar covalent. So just hold that thought if you haven't done that topic yet, which is probably not yet. So just as an update, just to make sure you definitely do write down these two main key points here. And so you can see here, I've also put a diagram in here, so you can clearly see that the electron's going to be attracted to the one that's more positive across the group. And as you go down, it's going to be less attracted because there's even though that is actually increased nuclear charge, the distance is far more relevant and it's further away. All right, so make sure you understand those 2 points. All right, so there's that information there again. Some textbooks will have slightly different numbers. This 1.8 might be 1.9 or 2.0, depending on the textbook or your data booklet, if that will give it to you. The QCAO one doesn't give it to you. There's a diagrammatic representation. Okay, that's often used also to indicate this is sort of the non-metallic character and metallic character. And I have these things extra. Please don't ignore that extra, because to date, in my opinion, QCA are adding extra stuff. They added Q, which I think is an added extra, although my colleagues disagree with me, which is fine. And they've also added in the recent act, so that was just a mock from QCAA, but QCA actually did a real Year 12 test a week or two ago, and they put the common ion effect, which is about buffers and so forth, which is not clearly in the syllabus either. So it is well within reason that these extra things are going to rock up on your exam, probably just to help with the bell curve, to be honest, and try and get those 99, those people that 0.01% to even out the bell curve and work out the top of the top, ones that are doing that little bit extra. And so electron affinity, energy released when 1 mole of electrons is attracted to 1 mole of neutral atoms or molecules in the gaseous phase. And so that is useful because once we start being able to put equations together, we can use Hess's law, which is coming up later, to solve various problems.